Alright, so in these questions, we have a question related to the compounded continuously questions. In this case, we can just use the formula of the future value and also with the help of the present value formula. So let me describe the formula first. The formula for the present value is the integral of the function and with the e to the power of minus rt dt. And then we will need to use this to put it for the future value. The future value is present value times e to the power of rt. So let's just calculate this. In this case, the ft is we can use either the functions or the initial fund. For this case, the initial fund is 1000. All right, and then for the r is the rate of the compounding. In this case, it is 8%, or we can use it as 8 over 100 or 0.08, depends on how we use it. And then for the t, we can just simply ignore it. Oh yeah, by the way, there is a big T here. The big T here is the time, how much the time is spent for that. It is, we can say it is, we have 55 minus 30, so this become 25 years. So based on this statement, we can just plug in the number into the formula. Okay, so now let's just put the number in. In this case, we have the t over here is 25. This is 0. The ft, it is the initial fund, it is 1000. And then we have the e to the power of minus the rate. We can use 8% or 0.08 t dt. All right, now in this case, because we have coefficient here, we can just put it outside to make it simple. All right, e to the power of 0.08 t dt. Now, how to solve this? On this case, we can just simply use substitution for this. I will just do it over here. We can use substitutions for the power here, 0.08 t. So if we want to find the du, it is become 0.08 dt, and therefore we get that dt is du over minus 0.08. All right, so let's just return to this integral. We have e and we have made this as a u, and then dt we can change this into du over minus 0.08. All right, afterward we can just put the minus 0.08. I mean, I think for more elaborations, I mean, it is like this, right? We can separate it there, and because this is a coefficient, we can just move it outside of the integral u du. So let's just calculate it. So this become the integral of e to the power of a u is the same, right? Integral of ex becomes the same, still ex, and then but no, minus 1 minus 0.08. So this become e to the power of u, but before we put the number, this is 0 and this is 25, I think we can change this into the initial form first, yeah. So this become e to the power of du is minus 0.08 t. All right. So and then we have to substitute this one, yeah. The t is 25 and this one is 0. So how do I do this? Well, we remember that if let's say we have after the integrations, let's say if we have 2x, if we want to substitute 2 and 1, this becomes 2 times 2 minus 2 times 1, yeah. So we put it here and then minus this one. So now for this case, this become minus 1.0.08. This become e to the power of 0.08 times 25 minus 0 times 0.08 times 0. Alright, and then how to calculate this? We can just change this into minus 1 8 over 100, right? And then later this become 100 over 8 to make it simple. And but then for the e to the power of this one, we can make it easier number, 8 over 100 times 25. Oh, there is e here, and then we can cross this become 4, 8 cross this become 2, and then for this case for the right side this becomes 0. Right, this become e to the power of minus 2 minus e to the power of 0. Alright, what is this? This is, for this case, we can divide by 4, I guess. This become 25, this become 2, theta over 2, and then for this case, I believe it's better to use calculator. By the way, this one is 1, e to the power of minus 2. You can plug it into the calculator. So this becomes 0.135. Maybe we can just round it up lah. Become 1/4. So and then minus 25 over 2 times this become 0.86. I suppose this is minus. All right. Not yet. Okay, now we have to go back over here. This become 1000 times, we have calculated here, right? All right, now we go back to the first part. We have calculated that this is 1000, and then we for this case we got that this is 25 over 2 times minus 0.82. Okay, this is 500. Oh my god. So this become, to make it easy, there is 2 0 here, right? 2 0 here. If we multiply by this become 5 times 25 times 82, and then for the double minus here, this become positive. All right. So let's just calculate the 82 times this one is 125 here. So that become as 101. This is 41. That become 164. This become 82 plus 052 1000. Wow. All right. So that's the PV. We got the PV over here. All right, so now let's continue. The future value is present value times e to the power of RT. So in this case we have the PV previously is 10,250 times e to the power of the R is 0.08 with times t, and in this case we got that we want to know the time when the future value when the time is 25 years from now. So the t here is 25, so then we can just put it the number 0.2 and 10,250 e to the power of this become 8 over 100. This is 25 cross cross, and then we divide, this become 250 e to the power of 2, and if you put the number e to the power of 2, this become, now this become 75,737.8283 to be exact. All right, so that's the answer.